Hey everyone, let's get started with another lecture video of CS2505. And in this one, we're going to learn how C input output things work, like CIO, basic IO in C, like how to use command line to communicate with your C source code or even use files. Okay, so yeah. Let's get started. Accessing a stream requires a pointer variable of type file. Okay, so just 1 second. I don't know why I have to fix this every time. So yeah, we are going to use a file. We are going to use a type called file. It is available in stdlib. So if you want to use it, you have to do a hash include stdlib.h. Okay, I think it is also available in stdio.h, but I can be wrong. Try to run it, and whenever you use like -w and -wal, it will specify whether it's included or not. Okay, so C provides 3 standard streams which require no special preparation other than the necessary include directives: stdin, stdout, and stderr. Okay, so stdin is standard input, and it's basically the keyboard or whatever you're writing on your terminal or command line. Okay, so it is the equivalent of scanner in Java, which reads from the stdin. So if you used scanner in Java before in your previous courses and stuff, then you used it to read from the terminal, and it makes use of the stdin. Okay, so then stdout. Stdout is the standard output, and it is the console window. So whatever you write in the stdout is going to show up in your terminal. Okay, so it is equivalent to using system out println in Java, and the out in this system out println is the std, like it specifies that it is the stdout, like the one we mentioned over here. I don't know what's wrong with my writer. I'm very sorry. So then there is the stderr. You can also make use of that in Java by using system.err.println, and it writes in the stderr, and usually it's in red line. Honestly, I need to get it fixed. So yeah, so you have this standard input output system. The bottom line is stdin is whatever you write in the terminal, and stdout is whatever is going to be shown in the terminal. Okay, so maybe in this course you will not be you will not be using WebCat at all. What you will be using is the terminal directly, and you will be making use of that stdin or stdout or stderr a lot. Okay, or of course you can actually read from files, which we will be seeing very soon. So writing output in the terminal. To print something in the terminal, we make use of the function called printf. So it's usual, like the default of printf is to print something in stdout. So this is what the declaration of printf looks like. It has a format specifier, and then it has ... as parameter. It basically means that it can have any number of parameters as it wants. So yes, you can actually put an infinite number of parameters in printf, and theoretically it will be able to accept all of them, and it will return an integer. It's basically the number of stuff it printed in the format specifier. So if you have like 4 variables over here, like a, b, c, d, it will print 4, like it will return 4. Okay, the first parameter is the string literal that specifies the formatting to be used. The remaining parameters, if any, specify the values to be written. The return value is number of the characters that were written, or a negative value if an error has occurred. So printing integer values. So we are going to try print some integer values. The specification of formatting is mildly complex. So first we declare two variables and then we try to print it. So this part is the format specifier. Let's see how it works. So if I run this code, and again it's in the GitHub repository, you can just copy it from there or write it from the slide. And for the best learning experience, I suggest you go with it with the slides. So if you run it by yourself, it will make more sense to you. Okay. So if we run this particular code, this is what's going to show up in your command line. Okay. So let's see the breakdown of it. So this part is the format specifier. Okay. And these are the format that is specified. Okay, so how it works is, this one means it's going to print a integer, and that integer is going to be this a. Then it's going to print a asterisk, and then it's going to print another integer, and that integer is going to be the second one. Then it's going to print the equal sign, and then another integer, which is a into b. So how it works is, whatever you write in the format specifier, they are going to be replaced with whatever parameters you are providing with. The sequence is going to be exactly the same. Like for example, over here, if you wrote something like a into b, comma a into b, sorry, comma a, comma b, it won't magically decide that this part is going to be here. It's going to just print it like this. This part is going to be here, this is going to be here, this is going to be here. So the sequence of the parameters is very important. However you write it in the format specifier, you have to make sure that the sequence is perfectly the same in as the parameters. Okay, this one is pretty straightforward, I feel like. And another thing is, by writing %d, you are basically saying that it's going to be a integer which is of base 10. Okay, so later on we will see how to make changes to this format specifiers, but right now this is the basic. So now we are going to print a functions variable like value as well. So we declare them just like before. Then we write something like printf, the absolute value of an integer is another integer and a new line. So as before, this integer is going to come from the first parameter. This integer is going to come from the second parameter. Okay. And over here, this integer is going to come from here. This integer is going to come from here, this from here, and that's the output value of it. I think it more or less makes sense, but you should give it a try by yourself so that you know that it's working. Okay. So in the second one, we see that the alignment is not perfect, right? So in the next slide, we are going to see how to make the alignments work. So we have been using %d directly, but printf has some special characteristics to make alignments and different other options. For example, if you put a number just before d, it's going to align it, right align it by the number w. Okay, so for example, if you write like printf %7d new line plus %d new line equals %5d, and then you know that it's going to replace this one, it's going to replace this one, and it's going to replace this one. but unlike before, they are going to be perfectly aligned as everything should be. So as you can see, there is enough gap over here. There is gap here and here. Give it a try in your command line and you will see the difference from the previous one. Okay, they are in the examples in GitHub again. Give it a try. Honestly, try to write these codes by yourself so that it makes more sense to you. Okay, if the value recurs more than the specified number of columns, then the width specifier is ignored and the entire value is printed. Okay, so now let's see how to print floating point values. But before that, I just want to remind you, %d basically means you are trying to print an integer. Now let's take a look at the floating point values. So over here we have two floating point values, double r equals 2 and double pi equals 3.141592, and we're trying to print it. The area of a circle of radius %f is about %f. So whenever we are using %f, it is a floating point. Okay, so there is something that you have to understand over here. If you write %f, that is going to be for a type float. If you want to print something double, you should be using %lf. Otherwise, it's going to be giving you weird output time to time. Like even in this one, it might give you a different output than expected. So remember, the format specifier works the same way. So we have a %f over here, right? It's going to be replaced by the first parameter. And the second %f is going to be replaced by the second parameter, which is pi into r into r. So if you try to print it, you will see that it has 2.00. That 00 like happens because we have specified that after decimal point there's going to be 2 digits, and over here we have specified that dot 4f. It basically means that it's going to have 4 digits after the decimal, so it's going to be 5664. So as you can see, 4 digits after the decimal point. So that's how you specify how many digits you want after the decimal. So %f means print a corresponding value as a base 10 decimal value. %w.pf means print the corresponding value right aligned in W columns and show P digits after the decimal point. Does that make sense? If it doesn't, try playing around with this code a little bit. It will make more sense to you. So let's try to print a table now. Okay. So stdio.h and math.h. So math.h is so that you can use some sort of math function. It has sine, it has cos, it also has sqrt, which is the square root, which we are going to make use of in this particular example. So I want to print x square root x. Like I'm just going to print it. There is no parameters here, right? So the form specifier is basically a string. Then we are printing this dot dot. So this part is printed over here. Then we are going to print 20 lines. Well, not 20, 19 lines. Okay. Well, honestly, that's 18 lines. You already know how for loop works. It starts from, in this case, it starts from 2 and stops at like 19, and it will go by 1. And what we're trying to print here is print 3D. So if you remember how we were printing integers, this is going to be right aligned by 3 column, and it's going to be right aligned by 10 columns with 4 digits after the decimal point. Okay, so let's see the output. You can try running it by yourself, and as we can see, There's going to be some alignment over here. It is also perfectly aligned, and they have 4 digits after the decimal point. So it's printing as we expected them to print. And there is an important note over here. So remember, in the previous lecture we talked about how to compile codes. So if you are specifying math.h, you have to specify -lm when you are compiling the code. Okay, this is very important. It's going to be in the next assignments or something, so don't forget this. Okay, if you do not specify -lm, it's going to give you some sort of error or like warning, and your code may not work even. So let's take a more in-depth look like what the format specifier looks like. So the general form of printf is as follows. It's going to have a percent to specify that it's a specifier. Then it will have some sort of flag. It will have a minimum width. It will have a precision. It will have a length modifier, and then it will have a conversion specifier. Okay, the format specifier begins with a percent sign. All fields except the conversion specifiers are optional. You will see why. First, let's take a look at the flags. Okay, so this is optional. It has like it more than one is allowed. It can be minus, which is left justify within the field. Right justify is default for numbers. Okay, so if you want to justify it by left side, you specify minus. Plus always shows leading sign for numerical outputs. Okay, so if you have like for example 2 and you specify the plus, it's going to be +2, and if it's minus, by default it's going to be -2. Okay, then you can put a space here. It presets the non-negative number with a space if the first character is not a sign. Okay, if you use a hash, it's rarely used. You can take a look at the documentation for this. Honestly, you will never see that in your life. If you specify 0, then it's going to pad it with zeros. Okay, and you cannot use a different padding character. Like if you wanted to pad it by 1, you cannot do it. So if you write something like %05d, then it's going to pad it by 5 zeros, and then like for example a number. Give it a try. For example int a equals 10, and then try to print %06d, and in the parameter you will specify a and see what happens. Okay, definitely give it a try. Then let's take a look at what minimum width and precision means. Minimum width is also optional. Add it with spaces if field is not filled, ignored if insufficient. You already saw examples in the previous slides. Precision is you know how many digits are going to be after the floating decimal point. Then there's the length modifier. You have already seen that. So it is also optional, indicates the value to be printed has a type that's longer or shorter than is normal for a particular conversion specifier. For example, if it's D, normally used for integer values. If it's U, it's for unsigned integer values. If it's HD, it's short, and if it's LD, it's long. Okay. There are other length modifiers. So it's usually used for like a U or H or L. Like in the previous slides, I have mentioned that if you want to print a double, it should be LF, %LF. This L is a length modifier. Okay. And of course, the last one, the conversion specifier, like what type of data you are trying to print. For example, if you specify D, it's going to be an integer. You can also use I for that, but I specifically prefer D, and most of the programmers also prefer D. You will probably never see I being used as an integer in this case. If it's U, it's an unsigned integer. If it's F, then it's a float. If it's C, it's going to be character. If it's X, it's going to be a hexadecimal. If it's S, it's going to be a character pointer, or let's call it string for now. It will make more sense to you later. If it's P, it's going to be an address. Okay, so these are very important, and you just have to, well, if you remember all of this, you're good to go. There are other ones, you can take a look at the references for more information. So let's take a look at another example of a C code. Remember, the C code always starts from main. For now, just ignore it. We are going to call a function called GCD, and over here we're just printing it. Okay, ignore this for now. Later on it will make more sense to you, so, but right now just let's take a look at here. Okay, this function is also given to you in the repository. Just take a look at there. You can just like copy the code and run it by yourself. So we are going to print in equals %d, %5d, and in equals %5d, and then we're printing the value of n and m, and then we are going to run a recursion. If you forgot how recursion works, maybe take a look at it again. If you want me to explain it more, I can totally do that. Let me know. Okay, if you run this code, it's going to look something like this. So as you can see, they are actually aligned, like right aligned by 5, because we have specified that, and you can see that the alignment is really nice. Okay, I mean, that's the only adjective I can use over here. So there are other stuff you can like try to print, like for example double. This is arc10, and we're trying to print it. We are saying that it's going to be left aligned by 12, and it's going to have the precision of 10. So you can actually see that over here, like for different like modifiers, we can see the differences of the alignment. Okay, so the alignment is more of a like aesthetic thing. It's usually not as important, but it's something to know about. Like instead of using like loop to make spaces and stuff, you can just use the alignments to make it look more comfortable to the user, right? So stdint has been added to the C library very recently. It's part of the C11 convention. So if you are going to use stdint, you should be writing std equals C11 whenever you are compiling it. So you can make use of them by using this. So instead of %d, you'll be using this. This is an example of it. So as you can see, like before there's a %d, then is being told that there's going to be 15, it's going to be right aligned by 15. Then you write it this, and notice that it has double quotes. Without the double quotes, it's not going to work, and it's honestly very weird because you are using double quote inside a string, and then you are putting this double quote here as well. In case I forgot to mention in this lecture, like for printf, the first parameter is a format specifier, right? That is always going to be a string, like %d, %d, or something like that, or like hello world. You probably have already noticed that most of them were strings, but like and you know that the string is going to end whenever it hits a colon, right? But in this case, it's not going to stop. It's going to take this part as something like %d. Okay. Again, try to do it yourself. It will make more sense to you. Like for example, over here we have a variable called n. We have n divisions variable. we are going to divide n by 2 and then try to print it. We are printing like 8 bits, and over here we're printing 32 bits, and this is what the output looks like. So you have already seen how to print stuff. Now you're going to take a look at how to scan stuff from stdin. So it is going to be equivalent to Java's scanner class. So let's take a look at how it looks like. So scanf has a format specifier just like printf. It's going to have infinite number of parameters, and it's going to return an int. So the first parameter is a string literal that specifies the formatting expected in the input stream. The remaining parameters, if any, specify the variables that will receive the values that are read. The return value is the number of values that were read, or the value of EOF, which usually is -1 if an input failure occurs. Okay. So if you write something like 10, 20, 30 in the command line, and you put like A, B, C as parameters to be read, then this integer is going to return 3. So it's always going to return the number of stuff you have read from the command line. Okay, so let's give it a try again. Try it by yourself. Okay, don't just like go through these slides and be like, hey, I have already covered it. No, you didn't. You have to try it by yourself. So let's say this example, I have two variables I and j, and I have a double called k. So we are going to do a scan, and we are specifying them to be integers, but you know that the k is a double, so it's going to have a weird output. Okay, that's why I'm telling you to give it a try. So whenever you're using scanf, make sure you put an ampersand before the variable. Why you're doing that, it will make sense after a while. For now, just think of it as a convention. Okay, like whenever you're using printf, you don't need any sort of like ampersand, but whenever you're using scanf, make sure you have an ampersand. Okay, so this is how you scan. In the command line, you will be writing 3 integers and pressing enter. Whenever there is a scanf, it will wait for you till you press an enter. Okay, so let's assume our input is going to be 17, 42, and the value of pi. And if we try to print it, this is what the output is going to look like. So I compiled my code. By now you should already know how to compile the codes, and you run it, and we are putting this input, right? And we see that the output looks like this. So why is there a 32? Because instead of using a %f over here, or more specifically %lf, because it's a double, we put %d, and it kind of threw the C compiler off, and it put very weird number in the %k, ampersand k. So if you want to make this work correctly, you should have written %lf. Now give it a try by yourself. Okay. I explain all of this. I keep going forward in the slides. So yeah, let's give it a try one more time. And again, we are trying %f over here. Definitely try %lf to actually make it work. The slides are like this so that you can learn from my mistake. Well, from Professor McQueen's mistake, because he intentionally did that so that you actually give it a try by yourself and see what happens. Okay. So when we try to print it, again, it's going to be right aligned by 7, and there's going to be like 4 digits. So if our input has like this many digits, it's going to drop everything and just going to get this part. Okay, and then it's going to print it. Give it a try yourself and see what it's going to print. Okay. Now we will see how to format the inputs. Okay, one thing I forgot to mention is over here we wrote %d and then put a comma. So in your input there has to be a comma. If you don't put the comma, the input is going to be very weird. For example, in this code, again it's given to the GitHub. In this code, try to input 1742 and 3.1416 and see what happens. Do not put the comma and see what happens. And then try with the comma, because whether you're using a comma or not is going to change the whole input process. Okay. So let's see another formatted input. So we are going to use scanf, and we are going to write %d dot %d. So whatever we are going to input, it's going to like separate it in two different parts, and we are going to put those parts in I part and d part. Okay, so if this is our input, this is how our output is going to look like thanks to this. Give it a try yourself, try to play around with it a little bit, it will make more sense to you. But the idea is, because our input is like this, so this part is going to be read as the first %d, and this part is going to be read as the second %d, and this dot is basically this dot. Okay. Um, yeah, and in this case, we are telling the scanf that I want to read 1% and 3 digits of the second part. So it's going to read this 3, then this dot, just like mentioned over here, and then going to read 3 of them, 1 4 1, and it's going to copy it in the D part. If we try to print this, we see that instead of reading the whole thing, it just read the 3 digits. So scanf's format specifier is more or less the same as the printf, but there are some new stuff. For example, if we put a star, it means that read but do not assign value to that object. So it's like a dummy character. Okay. Max width basically means like like over here we told it that like only read 3 digits, no more than that. So that's what the max width does. The length modifier is, they are optional as well. It indicates like LF or UD, just like before. And the conversion specifier is mandatory. We already saw that for printf. It's similar for scanf as well. So this is an example code. Again, it's given in the GitHub. So we have two variables. We try to try to convert it. Like what we're going to do in this example is input minutes and seconds and then sum them up. Okay, so let's see how the code works. We have a while loop, and this is very important. Like this is going to be very important for the rest of the semester. Okay, we have a scanf, right? And the format of the scanf is %d colon %d. So the input is going to be an integer, then there is going to be a colon, then another integer, then there's going to be a new line. Okay, the first integer is going to be put into minutes, the second integer is going to be put into seconds, and c it is equal to 2. So what it means is scanf is going to read 2 integers. If it ever fails to read 2 integers, it's going to stop. So basically, if you ever input like 1 or like 100, there isn't enough integers with separated by colon, right? So it's going to stop there. So let's see what happens. Okay, so we specified that it's going to read 2 integers every time. It doesn't have to be an integer, it just has to be like 2 stuffs, because we know that scanf always returns the number of objects it has written, like read. So in this case, it has read minutes and seconds. Okay, so it's going to be equal to 2. If you wrote 3, it's not going to work. If you wrote 1, it's not going to work. Okay, so that's why we had to write 2, because that's the how many of stuff we are reading in one line. So we are just basically doing some basic mathematics. You should be understanding what it means by now. And this is how our output is going to look like. So it's going to say total time, colon, and then %d, which is going to be replaced by total hours, another %d, total minutes, and another %d, total seconds. And this is how our output is going to look like. If you try yourself, try this input, and at the end write something random, like for example a or 100 or something like that, then it will stop taking input and give you this specific output. Give it a try. Okay, so let's try something by yourself. I'm not going to give you the solution directly. You have to try it by yourself, and if you fail, then ask me. This is more of a preparation for the assignment. So consider this number, okay? This 1042314. Now try to read it in a manner so that you can store the first digits in a variable. So basically 104 in a variable, then middle two digits in a second variable. So this 23 in second variable, and last two digits in a third variable. So 14 in another variable. Make sure you're only using scanf. Okay, like do not use loop, do not use if else, just try to use scanf to do that. Then try to print them separately using printf. See if you can do it, and if you can do it, the next assignment is going to be very easy for you. So we have seen how to work with the command lines. Now we are going to take a look at how to work with files. So to work with files, you have to open it first, okay? And it's very similar to the stdin and stdout. You will be using something like printf and scanf, but whenever you start working with the files, you have to open it. So it's similar to fopen in Python, I think. Even in Java, there is like file open or something like that. So in C, it has fopen, okay? And it's going to return a type of object called file. The first parameter is going to be the name of the file. The second parameter is going to be what mode you want to open it. So the available modes are read, write, append. Then there is read in byte, write in byte, and append in byte. And then R plus, W plus, and A plus. Usually this means like you can read, write, and do everything you want with that file. But you should see the reference for more information. We will be using this one mostly, R, W, A. Okay. So return value is file pointer, and if it fails, like if the file doesn't exist, it's going to return null. So if you want to read something from a file, you use if scanf. If you want to print something in a file, you use if printf. But unlike the printf or scanf, their first parameter is the file pointer that you got from the fopen. Okay. And whenever you're done working with a file, you use fclose to close the file. In C, it is very important that you close the file, because if you wrote something in the file and you didn't close it, many of the data will be lost. Okay. It returns 0 on success and EOF if it fails. So we're going to take a look at a very easy Caesar cipher, and in the next lecture I'm going to explain more about it. So you already know how Caesar cipher works. I have a message like computer organization, and if I shift it by like 3, then I get this. This is what the Caesar cipher looks like, right? So it's an analysis problem. Let's consider implementing a C program that will apply the Caesar cipher to a given text sample. Let's assume the user will want to specify the shift amount and the text to be encrypted. Let's also assume the user will want the case of the original text to be preserved, but that only letter should be changed. Okay, so our command line interface is going to be like Caesar. Then we specify how many amounts we want to shift it by, and then we specify the file we want to shift. Okay, so let's decompose the whole process, like how it's going to be. The first thing is going to be is validating this input format, right? Like if someone gives you a wrong input format, it should say that the input format was not wrong and it should close it. Then we have to process the input file and then print it, which I didn't mention over here, and then we exit it, right? So for validating the command line parameters, we have to verify the number of parameters, then whether the shift amount is sensible or not. I mean, it can be like over the limit of ASCII table, which is not nice. So we have to check that as well. And then we have to check whether the input file that was specified exists or not. And while processing the input file, we open the file, read next input character until no more exists. If character is a letter, compute its shift target, write shift target. I mean, we can just like print it, and then we close the input file. Okay, so this is what the front end is going to look like. There is a function called set shift amount, and there is a like check status part, and you already know how if else works in Java. That means you already know how it works for C. Assign the result of a function called, okay, so there is something interesting over here. So let's see what it's doing. It's calling a function with the argc and argv and getting the value, like return value of check params, right? And putting it inside check status. So how it's going to happen is then this check status is going to compare it against 0 because check status not equal to 0. So if the value of check status is not 0, it's going to return check status and stop the execution over here. Okay. It's kind of similar to Java, but you probably have never used it like that. So it's kind of something new, I guess. Then we also have to validate the parameters. Honestly, the parameters is not going to make sense to you. It will make more sense to you in the next slide. Not slide, the lecture. Okay. We're going to process the file and try to run it. And if we run that, we can see that the file is converted to this, and that's exactly what we wanted. So my suggestion is try to open a file by yourself and try to print everything that is in the file, or maybe write your own copier, like open a file, then read all the characters one by one using a loop, try to print it and see if it works. It's going to be part of your assignment anyway, but if you try to do it by yourself, you will learn much better. So yeah, that's all for this lecture, and I will see you in the next one.